Hello sir, I am Mayanku Vishwas from second year ECE. Today I am presenting classification of signals. We are discussing about 5 types of signal. First one, deterministic and non-deterministic signal, periodic and non-periodic signal, even and odd signal, energy and power signal, causal and non-causal signal. First we discuss about deterministic and non-deterministic signal. Deterministic signal deterministic signal behavior of the signals is predictable with respect to time. There is not uncertainty with respect to its value at any time. These signals can be expressed mathematically. X of t is equal, let's see the example. X of t is equals to sine 3t. It is the example of deterministic signal. So we can see there is not uncertainty with respect to time in this graph. So we can call it deterministic signal. Non-deterministic or random signals, behavior of these signals is random, not predictable with respect to time. There is an uncertainty with respect to its value at any time. These signals cannot be expressed mathematically. Example, any random noise. So it has a uncertainty with respect to time. Its value is not, the signal is not continuous. So we can call it non-deterministic signal. Next one is periodic and non-periodic signal. For continuous time signal, a continuous time signal is said to periodic it satisfied the condition, if satisfied the its condition xt is equals to xt plus t. T is time period of signal. Example, xt is equals to 3 cos 5t plus pi by 6. As it is sinusoidal signal, so it will be periodic. After solving, we get the value of t is equals to 2 pi k by 5, where k is equals to 1, t is equals to 2 pi by 5 is called the fundamental period. The value of t is equals to 2 pi by 5. We can call this fundamental period. If the condition xt is equals to xt plus t is not satisfied, then the signal is not a periodic signal. So we can get a value t is equals to 2 pi by 5 and it's called the fundamental period. What is fundamental period? The fundamental period is a period after that the signal is repeating. So we can call this periodic signal. And we have the example of this periodic signal, the sinusoidal curve. And the non-periodic signal signal example given below. So it so it uh, so it signal, that signal we called non-periodic signal. For discrete time signal, a discrete time signal is said to periodic if it satisfied the condition xn is equals to xn plus n, where n is always an integer. If the above condition is not satisfied, then the signal is said to be periodic. Example, x, the function of n is equals to cos 0.01 pi n. After solving, we get the value of n is equals to 200k. For fundamental period, k is equals to 1. So the value of n is equals to 200. The next one is cos x of n is equals to cos 0.01 n. N is equals to 200 pi k. For fundamental period, k is equals to 1. Then we get the value of n is equals to 200 pi. Now we can see n is not integer, so the given function is not periodic signal. So sum of two periodic signals. If a signal is represented by the sum of two periodic signals, then the signal of x of t will be periodic if t1 by t2 is rational number, where t1 and t2 is time period of two different signals, and the period of the function x of t is the LCM of two period. Let's see the example. X of t is equals to 5 cos 4 pi t plus 3 sin 8 pi t. So t1 is equals to k by 2 and t2 is equals to k by 4. For the fundamental value, t1 is equals to 1 by 2 and t2 is equals to 1 by 4. After that, t1 by we get the value of t1 by t2 is equals to 2. This is a rational number, so we can call the signal is a periodic signal. Next one, even and odd signal. Even signal or symmetric signal. It exhibits symmetric with respect to time. Satisfied the condition x of t is equals to x of minus t for continuous signal, and distinct signal x of n is equals to x of minus n. So we can see the graph of continuous signal and distinct signal, and they are just like mirror image, so we can call it the even signal. Next one is odd signal. The signal exhibit antisymmetric with respect to t is equals to 0. satisfied the condition x of t is equals to minus of x of minus t for continuous signal, and for distinct signal x of n is equals to minus of x of minus n. We can say a antisymmetric signal always passing through the zero or origin. But it is not necessary for even signal. Let's see the properties. For even signal, odd part is 0. For odd signal, even part is 0. Product of two odd signal even. Product of two even signal is even. Product of even and odd signal is odd. Even part and odd part. Continuous time signal, even part x of even part of t is equals to x of t plus x of minus t by 2. Odd part x of t minus of x of minus t by 2. Distinct time signal, even part x of n plus x of minus n by 2, and odd part x of n minus of x of minus n by 2. Example, x of n is equals to 4 minus 4, 2 minus 2, and x of n is equals to 4 minus 4, 2 minus 2. And then we get 0, 0, 0, 4 minus 4, 2 minus 2. And we can represent it graphically like this. The even part is x of even part is equals to x of n plus x of minus n upon 2 is equals to minus of 1, 1, minus of 2, 4, minus of 2, 1, minus of 1. And the odd part is x of n minus of x of minus n upon 2. So we can we get 1 minus 1, 2, 0, minus 2, 1, minus 1. Odd signal always start from 0. That is the conclusion. And we can say the odd signal always passes through the origin. Next, energy and power signal. Energy signal, the signal which has finite energy and zero average power is called energy signal. For energy signal, the value of E greater than 0 and less than infinite, and P is equals to 0. And we know that power equal to work upon time. For continuous time signal, energy is equals to limit of x of t square limit minus t to t dt. We can get the energy. And next, for distinct time signal, energy is equals to summation of minus n is equals to minus infinite to plus infinite x of n mod of whole square. Power signal, the signal which has finite average power and energy is finite is called power signal. For power signal, P is greater than 0, less than infinite, and E equal to infinite. So continuous time signal, we can say P is equals to limit 1 by 2t integration minus t to t x of t t square dt. For distinct time signal, P is equals to limit 1 by 2n plus 1 summation of n to minus n is equals to minus 1 minus n to n x of n whole square. So we know the power signal power equal to watt upon time. Next one is causal and non-causal signal. Causal signal, a signal is said to be causal signal if it is defined for t less than 0, x of t is equals to 0 for t less than 0. A signal is said to be causal if it is defined for n less than 0. X of n is equals to 0 for n less than 0. For causal signal, the value of causal signal greater than 0. So it's the graph is always in positive side. Non-causal signal, non-causal signal, the value of non-causal signal said to be non-causal when it is defined for t less than 0 or both t less than 0 and t greater than 0. So we can say the value of non-causal signal is it can be positive or negative, and the graph we represented and it represented the graph by positive and negative value also. Anti-causal signal, when a non-causal signal is defined only for t less than 0, it is called an anti-causal signal. We can see the anti-causal signal. We can see the anti-causal signal is the value is always in the negative side. A non-causal signal, a signal to a non-causal signal is called non-causal if it is defined for n less than 0 or for both n less than 0 and n greater than 0. X of n not equals to 0 for n less than 0. So we represented it by this graph. Anti-causal signal, when a non-causal signal is defined only for n less than 0, is called anti-causal signal. For this, so we can define it for this graph. The graph is represented anti-causal signal. Thank you.